Hello and welcome to this keynote session at Subsea World. This session is our technical panel on the technologies enhancing Subsea. Before we begin, I'd like to take a moment to thank all of our sponsors, especially our host sponsor Interaction, for helping to make the event possible. Please do take a moment to visit them at their meeting areas, even if it's just to say hi. Please feel free to ask questions throughout the session or just share your thoughts using the chat function. We're joined by a great group of speakers today, including our moderator, Natalie Bannerman, who's a senior reporter here at Capacity Media. Over to you, Natalie.
Thanks, James. Welcome everyone to this panel session on, the technologies that are affecting the subsea space, which I'm sure you'll agree is a very fascinating area. Before we dive into the conversation, I'm just going to give our speakers an opportunity just to tell us who they are and a little bit about what they do. Should we start with you, Lee? I can see you on the screen. Do you want to introduce yourself?
Yeah, sure. Thank you, Natalie, and welcome to everybody else. So I work for Xterra. I've been with Xterra for 3 or 4 years now, COO, but with specific responsibility for R&D and sales.
Perfect. Peter, over to you.
Yeah, thanks, Natalie. Hello, everyone. My name is Peter Swinkels. I'm the Vice President of Global Sales for Infinera Subsea Solutions. I've been with the company for 4.5 years, and my main focus is to drive our subsea cable upgrade business, which we have been growing since we entered this market about 11 years ago. During the last 18 months, I've been home-based in the Netherlands, but I'm looking forward to start traveling again and meet people face-to-face, hopefully in the second half of this year.
Perfect. Eduardo, over to you.
Hello, everybody, and thank you for inviting me to this panel. I am Eduardo Mateo. I work for NEC Corporation in Tokyo, Japan. First, I joined NEC back in 2009 in the research and development facilities in Princeton, New Jersey. Then I moved to Tokyo in 2012. And my role is I work as a director of network architecture and core technology development.
Perfect. Great. Well, we're going to dive right into the conversation then, gentlemen. I think it would be very silly for us to have a conversation about subsea technology without, of course, mentioning, SDM, which I think is the innovation that's making the most waves at the moment. From your various perspectives, how are you seeing this technology being, a real game changer? And I suppose more importantly, what do you think is next after SDM? Any thoughts there?
Would you like me to go first?
Go for it, yeah.
Okay, so the introduction of coherent transponder technology and uncompensated cable systems in the last 10 years or so have been extremely beneficial to the subsea industry. For years, the open cables and coherent transponder advancements, they have enabled significant increase in spectral efficiency and maximum capacity on these cable systems. However, we now get to a point where the projected capacity increases in coming years are showing signs of slowing as we approach the Shannon limit on these cables. So what we now see is that the industry is shifting its focus to SDM technology. So SDM is primarily a new wetland technology direction focused on maximizing the total capacity of the cable system instead of focusing on maximizing the total capacity per fiber pair as we've been doing for the last decade or so. This is done by increasing the number of fiber pairs, but consequently there's less power available per fiber pair, which means that they operate in a highly linear, highly predictable regime. For us as LTE vendors, that means that the focus is on having low noise in the transponder, on having a highly effective probabilistic constellation implementation, and the ability to tighten the channel spacing of the transponders, and also to increase the baud rate to reduce the cost per bit, the power consumption, and the footprint requirements. Just as an example, with SDM cables, if we start to increase the number of fiber pairs, let's say to 20 fiber pair or 24 fiber pairs, each running at 20 terabits per fiber, that means that you can get 480 terabits out of a cable system. And if you run those at 400 gig line rates, that means that you need to have 1,200 transponders at each end, which is, a significant amount, and that's where the focus of us in the SLT domain is going to focus on. Then in terms of what's next, the second part of your question, Natalie, in my view, the move to SDM cables is still very early days. So I expect at least the next 5, maybe even 10 years that the industry will continue to be focused on increasing the number of fiber pairs. Maybe eventually 40 fiber pairs, or maybe even more. I don't know. Maybe the wet plant guys can comment on what the maximum is there. And then beyond SDM, but I think that's still years out. We see potential increases in capacity by looking at introducing the L-band. Something that is quite common on terrestrial systems, but not yet on subsea systems.
Yeah, I think it's interesting that as we approach Shannon's limits, one of the things that drives people to look at SDM or increasing the number of fiber pairs, I think it's also something that makes it commercially possible, because there's less risk of your substantial subsea plant, your really big fat pipe, becoming technologically obsolete in a short space of time, which is what we used to see through the 90s and the noughties. And of course, the cost of money is very low as well at the moment, which also I think reduces some of the risk factor. So I think the push for higher fiber counts will continue for a while. I don't think there's too much drag on it yet. I think we will start seeing some technical drag, things that constrain the number of fiber pairs people want to put on a system or are able to put on a system. But for the moment, we're all as subsea system suppliers, at least 2 out of 3 on the panel. At the moment, we're racing to keep up with the market's demand for more and more fiber pairs on the cable.
Right. Any thoughts, Eduardo?
Yeah. Well, I think both Peter and Leigh kind of explain well where we are now and what is SDM. Maybe just a little bit of history of where SDM came from. The way, SDM came to the industry to basically solve one problem. Well, the problem was how to scale with capacity. Considering the fact that submarine systems are unique in a way that you have to power them from very end sides. So the current SDM systems that we deploy nowadays, in fact, they don't really use any new technology, if we put it that way. The technology, the building blocks were already there. If we consider SDM from a technical viewpoint, the only maybe technological new thing that we deploy is the so-called pump sharing technologies or pump farming. But in fact, those technologies were already deployed many, many years ago. So the key aspect of SDM is not the building blocks that we use, but it's the way we use them. And that is where the difference comes from. So as Peter mentioned, now we are not focusing on maximizing fiber pair capacity. We are focusing on maximizing total cable capacity. And the easy way to do that is to, instead of moving in logarithmic scale, which is the Shannon formula, and improving SLT technologies and getting higher and higher SNR or GSNR, instead of following that path, the path we follow is to add more bandwidth. More bandwidth means more fiber pairs, more amplifiers, and optimize the power consumption of each amplifier so we can keep up with large capacity. Now, as Peter mentioned before, with 24 fiber pair solutions that are qualified today on transatlantic systems, actually half petabit capacity, it's feasible, it's possible. We can power that. We can power that with standard power feeding equipment, so there is no need to go very large voltage, probably those capacities are not possible in Trans-Pacific range or beyond. So for that, we either reduce capacity or we need some improvements in powering. But certainly, current days SDM solutions can provide a lot of capacity. So I guess the question whether we need something new or what is coming next will be answered more on a commercial level or on a like an industry level, what is the amount of capacity per cable that makes sense on a particular route. It makes sense to have cables beyond half petabit capacity, or it makes sense maybe to have cables with lower capacity, but maybe a way to reduce the cost per bit in a way that more routes are deployed rather than single routes with a lot of capacity.
I think
so. I agree.
Sorry, go ahead. Matteo.
No. So I agree. Current SDM will stay for a while, and maybe we can talk about what is coming next, or maybe after Lee, if he has to say something, we can comment on my views or others' views of what is coming next.
Yeah, I think at the moment SDM has been just, if you like, just about adding fiber pairs. I think it will drive technical change in different directions in the future. And as Matteo has already referred to, I think obviously a substantial area is the powering. So we could see developments in the cable, we could see developments in the joints, probably both are necessary, higher powered PFE, and power efficiency, how we use the power within the repeaters and within the branching units becomes far more important. So, we've tried to think about this ahead of time and have a patent on powering efficiency within the system, powering each repeater specific to its need for power rather than a single overall power level for the system. And that gives around 20% improvement, but there's much more is going to be needed. But we could also see the architecture of systems change. Trans-Pacific systems, if you're limited on power, we'll probably see more systems stop in the middle somewhere to allow powering from a midpoint, rather than trying, as has been the case for the last few years, of constructing them point to point, end to end, and missing out the midpoint, which added cost with little value.
Yes.
So, go carry on. I was going to say, Eduardo, did you want to address on what you think was next?
Yeah. Before that, I agree with Lee. I mean, I think right now the focus is mainly on how to improve the power efficiency of components. We see actually fibers getting built with lower and lower attenuation. We can actually observe cabling attenuation values below the limit of 0.15 dB per kilometer, which is extremely low. And low attenuation in the fiber helps with powering. Focusing on how to improve repeater efficiency is very important as we add more fibers, more amplifiers, not just from a pumping perspective, but also on the electrical architecture of the repeaters and how to improve power efficiency. And I think there's still room for improvement there. But again, the fundamental building blocks will still be like pure silica fiber and EDFA amplifiers. So each company will arrange things the best way they can to maximize power efficiency and so on. Now, if we look at what's coming next, as we said before, right now we have just the same building blocks as many years ago, arrange them indifferently. Maybe it's time to think, if we continue to scale up with capacity and we need still power efficiency, I think it's probably time to think of something more disruptive. Maybe there could be multi-core fibers with the multi-core ecosystem. It's still to be determined whether they can improve the cost per bit elements of cables, which is eventually what we all need to improve at the end. But it certainly there is room there for make some disruptive changes, especially in the space of things that occupy a space in cable, a space in repeaters, and hopefully gaining space efficiency will translate into cost efficiency and eventually power efficiency. but those are earlier stages as of today.
Yeah,
that could be one potential direction for next generation SDM.
absolutely. Yeah. I mean, you've all touched on so many of my kind of future talking points. It's kind of hard to circle back, but I think one thing I was, curious about, and we've spoken about before this, but this idea of increasing number of fiber pairs. Eduardo, you mentioned NEC has recently qualified their 24 fiber pair system, etc., and obviously taken into consideration the commercial case for it, as you mentioned. Do we think that we're going to kind of get to a point where it will we'll no longer be able to kind of just increase the fiber pairs? Will we kind of reach that end point? Will we just kind of continue to increase the fiber pairs as and when it's needed? How do we think that kind of trajectory will look?
Let me start with this one. Yes, you're correct. NEC recently qualified 24 fiber pairs. I think that there is not an easy answer to that question. My answer for that will be that I think number of fiber pairs or number of core pairs, or in general, available bandwidth of a single cable. I think that now it becomes more practical to talk in these terms. It will continue to increase as long as it's commercially attractive. And it comes back to the question that we put before. Does it make sense to have a petabit cable or not? I mean, I think if the industry requires or asks for petabit systems, I think we'll find a way to make them happen. Either using multi-core fiber, either using optimizing the bandwidth of the EDFA. There could be ways to do that, increasing the PFE, but it has to be cost effective. So what doesn't make sense is to build a petabit system that is more costly than 2 times 2 half petabit cables, right? So that is where we think we need to see. There are no fundamental limits on adding more fibers. You can still make bigger cables. The question is whether those bigger cables can be easily deployed with the current vessels and so on. If not, you can use multi-core fibers, which give you a tremendous advantage in terms of density. But again, we need to power these systems and they have to be commercially attractive. So
yeah, I think it's an important point. It's not just a question of whether a petabit cable is more cost effective than 2 times 500 terabits, if I've got that right, my scale of units. But the other question is whether operators or content providers want to see that much investment into a single cable. Exactly. Rather than perhaps having diversity in their network or adding to the mesh rather than simply creating a big pipe in one direction. And I think some of those commercial considerations will weigh into the decisions on number of fiber pairs. So we might find there's a natural commercial limit to the technology, but I think if there isn't, I think we will see practical technical limits to it, which, as you said, may be because cables start becoming difficult to handle and people start asking whether we don't need turntables for deployment because they're too stiff to coil properly. We could find that jointing becomes more difficult. The joints almost certainly need redesign as we get fatter cables. So there could well be other technical limits to simply adding fiber pairs. Not least perhaps the space inside the repeater, of course.
Absolutely. Any thoughts, Peter?
This is really the core competence of the 2 wetland providers on this panel, not so much for us. I think we obviously, as a SLT, as an upgrade vendor, we watch this very closely, and we do have thoughts on what it means for where we need to focus our efforts in developing our next generation transponder technology, which is really about higher baud rates, very efficient probabilistic constellations, shaping schemes, and some other things. So we're focused on that. At the end of the day, more capacity on cable systems means more SLT technology for us. So the more fibers, the better it is, I would say.
Yeah, absolutely. Well, kind of carrying on from that then, one question again, that I've always been curious about is, the standard life cycle of the subsea cable, as far as I know, still stands at about 25 years. With these new, innovations and technologies like SDM, do we see in the long term there being any kind of growth or prolonging of the subsea kind of life cycle? Will we eventually get to the point where we create cables that can last 50 years in the water, so to speak? What do you think?
I think it's obsolescence, either commercial or technical, that's going to affect the life cycle. I don't see vendors, I can certainly speak for Xtera, I suspect NEC will feel the same. I don't see any move to extend the life cycle or the design life of the cable. So I think 25 years has proved to be a reasonable match to what the market needs. I think cables will start getting taken out of service, whether they're SDM or not, when the O&M cost per bit is overtaken by the newer cables. So if we, as Matteo says, if we succeed in going from 24 to 40 fiber pairs or wherever, then the cost per bit of the maintenance or O&M cost per bit of that newer cable is going to be substantially less than for the older one, even at 24 fiber pairs. And so it will render the older cables redundant or obsolete sooner rather than later.
Yeah.
But I don't think, there's not many 24 fiber pair cables out there yet. The industry could supply 8 fiber pair cables for about 10 years when the customers only bought 2 of them. So there's still a question as to what the take up will be of the higher fiber count cables. And there's probably, we can all name them, there's probably only a few customers in the world who are actually in that market. There are other segments where SDM is not particularly relevant, and lower fiber counts will prevail. Matteo, sorry.
Yeah, I agree. I'm not an expert on understanding the cost of O&M, operation, maintenance, and certainly probably we will need people here that really operates cables to tell us what are the parameters they use when they decide to decommission a cable, or when they realize that they need a new cable compared to potentially extending the lifetime of the cable. From a technology perspective, there is something interesting, actually. I have seen both directions. I have seen people asking the wet plant suppliers, can you make cables systems cheaper if the lifetime is 10 years instead of 25? And you see other type of people asking, can you make cables last 50 years? So these two approaches are completely different. One thing is interesting, as Peter mentioned. I mean, right now, the transmission, from the transmission perspective, cables are relatively simple. We just provide bandwidth, dispersion, uncompensated, digital coherent transponders take care of everything. So technology obsolescence is no longer an issue as it used to be with traditional dispersion managed systems, where digital coherent transponders came, and then it didn't make sense to extend the lifetime of a cable because operating that cable or upgrading that cable was way costly than making a new one. But right now, standard digital coherent technology can be used in the same way with cables today, and cables probably to be built 10 years from now, unless we see something really disruptive that requires a new SLT technology, but might not be the case. So it might be not so costly eventually from an upgrade perspective. If a cable doesn't have a lot of repairs, if a cable health is pretty well, it doesn't really, there is no real need to terminate the lifetime of that cable. It can continue if the repeaters are healthy beyond 25 years, and transponder technologies can continue to add capacity efficiently. So it's an interesting debate. Yes, it's an interesting debate.
Yeah, I totally agree. Actually, there was an announcement a few weeks ago by Global Cloud Exchange. They had Pioneer assessing their network on a technical basis to see how reliable the network still was, and they basically got a kind of a rubber stamp saying this system can be technically extended for another 5 years or so. And what I'm seeing in certain parts of the world is that there's need for new cable systems, but it takes too long for them to being deployed. So some of the really old cable systems there's still actually really good money to be made by the owners of those systems, because with the latest technology, the latest generation of coherent technology, we sometimes find during field trials that we can do 50% more capacity compared to the previous technology or previous generation of technology on these older cable systems. And all of a sudden, this becomes interesting for them. They can compete in the market and they can extend the economic life of cable systems. So 25 years is a relative term in subsea. I mean, there's examples of systems that were really successful and only lasted 10 years, and there's systems that are way beyond 25 years already and still operating successfully. So
Absolutely.
Southern Cross has had success extending the life beyond 25, and
yeah.
We'd like you to be a little less successful, Peter, I think, at extending the life of cables by adding a load more capacity to an existing subsea plant, but well done anyway.
We don't mind.
Perfect. Well, before I move on to the next question, I just want to remind our audience, to submit any questions that they have for our panel at any time, because we will be coming to some questions at the end. So don't be shy, send through your questions as and when you feel. But yes, if we then move on to, kind of some of the more kind of emerging or maturing technologies, depending on how you look at it, things like, artificial intelligence, machine learning, or even machine to machine. Now, usually when we hear about these technologies, we don't hear about it in the kind of the subsea related context. We think about them very much in the kind of, the managing of terrestrial networks, etc. Do any of you have any views on, whether or not any of these innovations, will or are having any effect on the subsea space? Are we seeing any influence of these technologies at all?
We Tony Frisch, who works for us, published a paper on using artificial intelligence to make AMP adjustments. And so I think, and it's typical of an early adoption of a technology. You start to get these papers, and then eventually people industrialize the application. I think our view is because AMP adjustment is typically part of commissioning, and then we all hope the customer gets to leave the system alone for 25 years. So it's more likely, I think, that these kinds of software tools or applications will be applied to things that need more frequent adjustment or more dynamic adjustment. So typically, I think they're likely to find a home in the transponders or in the dry plant rather than in controlling the wet plant. At which point I should probably pass over to Peter or to Eduardo.
Yeah, I guess from Infinera's perspective, we are looking at integrating machine learning or AI algorithms into our next generation transponders. We do this as a way to deal with some of the nonlinear compensation in a more efficient way. So that will help primarily on some of the legacy cable systems out there to get more capacity out of those. We're obviously also a terrestrial vendor, so this year at OFC there was a big theme about low margin networks, how to use telemetry from the transponders, machine learning, etc., to better predict fiber degradation on terrestrial systems and how to act on that as an operator. So that is something we as a company are very much focused on. In the subsea networks, the operators, what we see in the last few years, have already are quite common in investigating low margin operations. So they've been doing that for the last few years already. So I expect the impact of that to be less than compared to terrestrial networks, but still the use of telemetry and machine learning will certainly be very helpful for subsea operators as well.
Yeah, I agree. I mean, it's no news for everybody. I mean, AI, machine learning is a hot topic now. And, a lot of people is looking at that. There is tremendous amount of investment there. So it would be hard to believe that nothing comes out of it. I think from optical communications perspective, we can maybe separate in two aspects. One is the networking aspect, as Lee mentioned before. I think AI and optimization tools or machine learning has a room there for optimizing networks, mainly in the terrestrial area, where you have ROADMs and wavelengths rerouting here and there. So there's certainly an application there. Submarine systems are mainly point-to-point nowadays. There is not that networking complexity. So perhaps those type of applications will not come to the submarine space as soon as we need it, or maybe we don't need them at all. And then there is the transmission aspect, right? As we mentioned before, submarine systems is all about getting capacity for a given budget of powering and at a reasonable cost. And whether machine learning or artificial intelligence can help on that, it's still TBD. I mean, transmission, machine learning doesn't really solve problems that can be well modeled by the current physics. And transmission, especially in systems like we have today, dispersion uncompensated transmission can be extremely well modeled with various mathematical tools, and including nonlinearity compensation. NEC actually started the use of AI for nonlinearity compensation in transponders. We published a Nature paper a couple of years ago. But in reality, there are other ways to implement nonlinearity compensation that can be also efficient. So from a transmission perspective, I don't really see the need of AI, or I don't really see AI certainly improving SDM technologies to a way that something can really benefit the customers. But networking, maybe there is another aspect like fault localization, fault analysis, understanding well what happens or identifying when a cable cut happens more efficiently. There could be some room there. And as Lee mentioned, tweaking and understanding the EDFA behavior, that is becoming now common practice, using machine learning for arbitrary inputs, how to understand how the EDFA works. And maybe, yes, in the future, if we eventually have, for example, adaptive equalizers, if we add more complexity to the wet plant, yes, there could be a way that machine learning can help to optimize, for example, the gain profiles and the equalization profiles after repairs and so on. So I wouldn't be surprised that in a few years we'll see more AI tools in our industry.
Absolutely. Yeah, I think to your point, Eduardo, it will probably be used as a tool in some part of the ecosystem, that's for sure. But we'll wait to see how that develops. Okay. So then, if we move then on, one question I had was this prevalence that we're seeing at the moment for I call them loop-based systems. Some people refer to them as kind of mesh-based systems, and how they are, in my view, coming more and more popular and probably the norm, depending on your view. What do you think in terms of these kind of systems as a way to added network resiliency? Do we think that's a good way to kind of approach that? Any views on those systems in general?
Well, if I can start, sure. I think it's important that we first need to be clear on deficiencies, the definitions here, right? So as already mentioned, subsea cable systems are still typically point-to-point systems. Mm-hmm. Look at the classic transatlantic and trans-Pacific routes. They're all point-to-point. Mm-hmm. There are some mesh-based systems in Southeast Asia, but I would certainly not call that the norm in the subsea space. What we obviously do see is that the global operators, like the internet content providers, for example, they're building their global networks by interconnecting their subsea and by the way, also the terrestrial cable investments together in a global mesh. And they do that to increase their network resiliency and availability. And what we also see as part of that development is that they use optical express at the cable landing station to continue the optical path beyond the cable landing station and terminate the signal across a terrestrial backhaul in the data center or in a POP location. Typically, these terrestrial backhauls, they're on redundant routes again to improve network availability, and some of them are loop-based backhauls. So it's definitely an important trend, and especially for high capacity cables and high capacity users that they build global networks. Where this, by the way, matters for subsea cable systems is they need to be aware that there is a need there for active power management. This has to do with the fact that the way the power management is done on subsea systems compared to terrestrial systems. And if you start integrating those two together and have complex backhauls, and then if you then also start adding spectrum sharing, for example, it really requires an intelligent power management solution for that. We have a lot of experience at Infinera in doing this because we've been doing this for, like I mentioned, more than 10 years. And I can assure you, this is not a trivial capability to develop. But we have developed a software suite in this field that we deploy with our customers to help them achieve this.
Yeah, and on our side, we've gone down a very similar route. So our gateway product on the open systems, pays particular attention to the loading and, as Peter says, to the optical power management. We used to see loop systems in the subsea. Again, probably in the 90s, a number of systems were built that way. Now, nearly all point to point. People are chasing bigger pipes rather than diversity within a single subsea system order. But clearly, at the operator level, any operator of any size is looking for a mesh network, which means multiple subsea routes. They may not build them all themselves. They may purchase capacity on somebody else's system. And again, as we move to SDM cables, that becomes more possible. So I think we'll see different approaches in the future. But I think from the point of view of the subsea system suppliers, the infrastructure builders, what we will build is largely point-to-point systems. Although I do see, as Peter says, strong trend to loops, or at least built-in redundancy on the terrestrial backhaul route, which perhaps reflects, that they're more risky than the subsea system.
I think this is an interesting point. Nowadays I think cables, submarine cables, are interconnected in the land, right? In the landing stations or in the POPs, and yes, we all need to understand how to manage power control and dummy lights and so on. But I think that there could be some changes here with the advent of SDM. So SDM provides now a lot of bandwidth and a lot of fibers, and users can now. So traditionally, of course, the bandwidth of submarine systems is valuable, is relatively expensive compared to terrestrial. So people focus mainly on point-to-point, optimize your bandwidth, optimize your capacity. But if we get into a point where now cables, the cost per bit gets to a level where you can do more things rather than just transmit point-to-point, whether it's adding more connectivity to your systems. It's true, as Lee mentioned, that the primary motivation is point-to-point. But now, if we think of 24 fiber pair solutions, or even in the future 32 fiber pair solutions, it doesn't mean that we need those to build a trans-Pacific pipe. we may need those to connect a 12 fiber pair system on a particular branch where every single user of that trunk wants to have bidirectional connectivity to a particular location. And that's another application of large fiber count systems. So when you end up with, now we are developing, and I think all the submarine suppliers are developing full optical fiber pair switches in the branching units. And we have now high density switching capabilities in branching units up to switch 24 fiber pairs. So that could enable a different way of operating fiber pairs for diversity, for resilience against cable cuts. We have seen, for example, initiatives implementing fork architectures where you have a big trunk. Let's say, think of transatlantic, you have a big trunk across the Atlantic, and then you split your fiber pairs to two different locations in the east or in the west, and then you can use either one depending whether you have cuts. You can actually interconnect those terrestrially. So I think the point I want to make is that the more fibers we have and the less the cost per fiber, it becomes more applications may open. And finally, a final remark I want to say, and it's true what we are saying, that mainly we are still see of submarine systems as pure transmission, but I don't see, let me put it in a different way. There is a possibility that people start thinking of creating cable interconnections under the water as well. So this is things that are being discussed early stage. And there is a possibility that we see those in the coming years. So we'll see. Again,
is that from different vendors?
I cannot speak, but usually, I mean, the amount of vendors is not big, so I believe most of the vendors will work on this. But this is, I mean, it shouldn't surprise anybody. If you think about it, Peter and Lee, submarine systems usually follow the trend of terrestrial. So things that you see being doing terrestrially, look at ROADMs, for example. Mm-hmm. WSS ROADMs were deployed in the terrestrial long time ago. In the beginning, people thought, you know, how are you going to put a WSS under the water? It's too complex. It's a lot of complexity. Now all the ROADMs are WSS in the web plant. So eventually, the type of optical switching cross connects that you see in terrestrial, I believe will gradually move to the submarine. Again, if it makes sense commercially, of course, and mm-hmm. especially if the cost per fiber is reasonable.
Yeah, interesting.
But I don't have a crystal ball, so who knows? I mean, it will depend on the applications and what type of network our customers require.
Absolutely. It's a really interesting point you're making, Eduardo, and I think I think it'd be interesting to see how that progresses. I mean, before I move on to the next question, we actually have got an audience question, so I want to make sure we have time to answer this one. So somebody has asked, from a technical point of view, is the industry ready for an Arctic route? As we know, we've seen many times, you know, the stories of various companies kind of trying to implement a subsea cable in the Arctic, but any views there from a technical perspective, whether or not we'll see that?
Yeah, very interesting question. And the idea of an Arctic cable has been around now for 20, 30 years. I mean, there is the Quintillion system approaches those regions and I think incorporates some technology that on the installation side, I think that meets the much more demanding environment as you get into those areas. Certainly, I can see the market would like one, you know, from a latency perspective in particular. Whether the commercial issues that it raises, you know, if you get a break in the cable, it could be quite a number of months before you're able to get there to repair it, for example. Is that acceptable to the customers? I'm not sure. I think probably the burial and installation technology exists to do it. I don't think there are particular issues on the transmission or the subsea plant side. But it's a very interesting question. Interested to hear Peter and Eduardo's views on it.
Yeah, I agree. I don't really see from the viewpoint of wet plant technologies, repeaters and cables and branching units, whether it makes a difference having an Arctic route or not. I believe it's mainly related to the implementation, installation, what to do if the cable is broken. I mean, yeah, there could be ways, maybe more specific ways of designing the network, maybe additional reliability, for example, certainly against shunt faults. But those approaches are already being deployed in any other cables. So I'm not sure whether I can see any changes.
I think there's some interesting geopolitical points as well for most of those routes, but that's probably out of the scope of this discussion. Sorry, Peter, I cut across you.
Yeah, no, I was going to mention that. I mean, first of all, from a technical perspective, from an SLT perspective, there's no technical limitation there. Actually, the route is shorter than most other long distance routes, so technically there's no issue from an SLT perspective. But commercially, geopolitical, permitting, I guess there are some challenges there, and that's probably the main reason why it's taking so long to actually get it done.
Just to not to make you repeat yourself there, Peter, but I think there's been a follow-on question just to ask if there is any limitations on if there is any power requirements, specific power requirements for an Arctic cable, but just following on from what you're saying, that there is no kind of technical limitations in regards to power either?
I don't think so.
No, I mean, from optical power, certainly not. Electrical power, I mean, the routes are shorter than some of the other transoceanic routes. And so, you know, for as long as the industry can manage transoceanic routes, from a powering perspective, electrical powering perspective, the Arctic route isn't an issue. I think most of the questions that would be asked would be around maintainability. How would you ensure that it survives as best as possible? Are the survey techniques sufficient to ensure that ice scour is properly understood, so you know where to protect it properly, and so on? Issues around it's physical issues rather than technological issues, if you like.
Yeah, I agree.
Yeah. Well, we've just had a bit of an influx of questions. I think everybody's starting to warm up now, so we're going to carry on so we can get to some of these. So somebody says their question is about latency, is one of the major factors affecting cable route and cost. Apart from using direct routes and high-speed ports, are there any other ways of improving latency across subsea cables? Anybody want to take that one on?
Well, I mean, other than finding the best route, which is the obvious one, from a technical perspective, the only way to reduce latency is to reduce the speed of light, and that is
increase. Increase.
Well, yes, reduce the time. Yes, increase the speed of light. Yeah, and there are fibers that can do that on the research level, and I mean, people are probably familiar with the concept of photonic crystal fibers or hollow core fibers. Those are still on research stage, but the fact is that we are seeing tremendous improvements in the past few years. These fibers have the advantage that most of the light travels through air, so refractive index is small and speed is fast, but the attenuation is very large. So it's not really practical to deploy these fibers as of today. But the attenuation levels that people are reporting nowadays are becoming, I wouldn't say competitive, but certainly we can look at them in a different way. I mean, just a few weeks ago at the conference, one group in I think the Southampton University reported for the first time that hollow core fiber can have actually lower attenuation than than silica fiber in certain wavelengths, not in the telecom wavelength, not in the C-band yet. The C-band is still worse. But in other areas of the spectrum, they reported for the first time that hollow core fiber has lower attenuation. I mean, if you say that 10 years ago, nobody would believe you, and it happened today. So we'll see. There is a possibility that maybe this type of fibers could be explored if really latency is something that we really need to improve.
Yeah. I think it's interesting because by far and away the biggest factor affecting latency on subsea cables is just the length of the cable, far and away. And for sure, we don't build cables any longer than they have to be. But there is a trade-off made typically between the level of security the customer expects and is prepared to live with or without on his cable, and the shortest route. So we build on the shortest route possible, but that does involve trade-offs between safety of the cable and distance. I also think latency matters in the industry, but often there are other concerns. So the number of cables that are built where latency drives them are very few, in fact. Hibernia Express was one, and Ellalink capitalized on an underserved route, and one of its major pitches is latency. It's an improved latency route from South America to Europe. But there's not so many cables that you can point to like that. So I think there are often other factors than latency driving the routing decisions, landing point decisions, and so on.
Absolutely.
Yeah, and let me add something again. Latency matters in relative terms, not in absolute terms.
Yeah.
So it's important. Yes, if you can build the same point-to-point cable in a shorter route, that helps because there is a relative improvement. But let's say I mentioned about hollow core fiber. If everybody deploys hollow core fiber, there is no latency improvement in relative terms. So suddenly you wouldn't lose the point. So I think also we need, from a technical perspective, things will make sense if we address a problem that has to be solved. And I think latency, people don't really need to get faster to places. People really need to get faster than others. So that is what has to be addressed, not pure speed, I suppose. But again, I'm not an expert on this.
I think it depends who the customer is, doesn't it? So for some customers, absolute speed matters, and for some, relative speed matters.
Yeah, that's true. That is true.
Yeah. So I'm going to quickly jump onto another question because I don't know what has happened, but we've just had so many questions come through, which was always great. But one that is really interesting here. Somebody has said, how will a satellite network like Starlink influence the future for subsea cablings? Any views on that at all?
Wow.
I think so. I guess my view on this is that it might have some impact in certain parts of the world, which are difficult to be reached by submarine cable systems, technically, or that it's commercially difficult to make the investment of a subsea cable systems. But in terms of replacing subsea systems on the Atlantic, for example, I don't think that will ever happen, because just looking at the sheer amount of capacity that is required on these routes like transatlantic, transpacific, you just cannot do that via a satellite network. It's just impossible. It would be cost prohibitive.
And I think
that's my short answer to that.
Yeah, and I think subsea cables, even compared to low Earth orbit satellites, still retain some latency advantage, quite aside from the substantial capacity advantage, as Peter talks about. So I think it will aggregate or allow to aggregate more users onto subsea cables. So I think it's I would probably see it as a complementary technology rather than a competitive one.
Absolutely, yeah. I'm going to do one more question, and then hopefully we can wrap up at our end. So somebody has asked, it's a bit of a specific one. They said that there are recent announcements on the Africa to Europe routes by Facebook and Google. Are any strong business case driving these, or are we heading to huge capacity glut, especially with poor and mostly non-existent inland terrestrial offload circuits? Good for the market, but good for subsea cable operators. any views on that?
I think not any great view. I think I wouldn't bet against Facebook and Google.
Sure.
I think they know what they're doing. And I think, again, it's more about getting users onto the global internet and giving them proper access than perhaps about, it's not a long haul cable, really. It's an aggregator from multiple landing points. Just a quick view.
Yeah, if you look at the African continent, there are a significant amount of users that once the development starts or continues, I should say, I guess, will be potential users, customers of the big ICPs, driving further development, economic development in those countries, in that region, developing again the need for more capacity requirements, etc., being connected to the global internet. So personally, I think it's a really good thing that this happens. And let's hope that it actually brings a lot of economic prosperity for the continent.
Absolutely, and it's worth saying perhaps that anywhere that needs one subsea cable, as soon as you get used to that quality of service and speed of service generally, back to latency, then very soon you think you need a second one because you couldn't afford to live without the first one in the event that there was ever a repair. So, two cables, one Facebook, one Google, why not? And indeed, more cables than that, I'm sure would find their market.
Well, I'm going to then jump to my last question then, because so many things we could continue to talk about, but I think it's important to kind of get an idea of how your respective companies, or you within your respective teams, what you're developing in the subsea space, because often these are the innovations we'll be talking about a year or 2 years from now. So what is your kind of focus areas in terms of research and development, etc.? Should we start with you, Peter?
Yeah, I'll keep it short. For us, it's all about helping our customers to sell more capacity on their cable systems. And we've spoken today a lot about SDM, but let's not forget that there's 500 cable systems out there, of which only a few are SDM. 80% are actually the legacy compensated cable systems, 20% are uncompensated. We are very much focused on helping all of our customers, so also the ones with the legacy cables, the older cable systems. We are 100% confident that on those systems we can help our customers extend the economic life of those systems. We do that with the i6 technology, which is now shipping to customers globally, and we will continue to do that with our next generation that is currently in development as well.
Absolutely. Lee, over to you.
Yeah, I mean, I'll try and be similarly brief. We've already talked extensively about SDM. I mean, our target is to keep up with the market demand for SDM, whilst still providing the active supervisory or command and response supervisory within our repeater, which we think is a core and essential technology if you want to understand the health of your subsea plant. I think as much as we're also looking at providing the flexibility on branched systems that the customers are looking for, band switchable and ultimately WSS. I think in the regional market, we see the band switchable providing the flexibility that's needed. Probably as much as anything, the focus at the moment is on ensuring that we have capacity, which we still have, which stems from the business model that we use and the flexible sources of supply that we have for both cable and marine.
Eduardo?
Well, yeah, I mean, I guess not much different from what Lee said. Our focus, we have, of course, many R&D areas and directions in the company, but the main focus, of course, is moving beyond SDM, which is answering the demand of the industry, in terms of capacity, in terms of reliability, in terms of connectivity. I think our main focus now is to look a bit further away and see what is next. And that's what we are working on. We call it Generation 2 SDM. And whether that will deploy different types of fibers or different types of architectures, the main focus always will be to improve the cost per bit for our customers and be able to implement longer systems, more power efficient systems, and in a way that, of course, more customers and more parties can enjoy submarine capacity. So, of course, that involves a number of technologies in many areas, but that's what NEC is working on.
Perfect. Well, that was my last question. I think we could carry on talking for a very long time, but it's a great place to start. Thank you so much for joining me, and I'll pass back to James. Thank you.
Thank you, Natalie. And massive thank you to all of our speakers for addressing those audience questions, which it's great to have. So please keep them coming in future sessions. Just before we finish, I'd like to take another moment to thank all of our sponsors for helping to make the event possible. This session will be available on demand for the next 30 days. So if you'd like to watch it again, or you've got a colleague who you think would enjoy it, please do let them know. This is the last session for today, but I look forward to seeing you all tomorrow at 10 a.m. for our EMEA Spotlight panel. There's some great speakers on as well. Thank you all for joining. I look forward to seeing you soon.